Ah, 1947. It sure was a different world back then.
What do you mean?
Well, the war was over, our troops were home, and life was returning to normal. But these three men were about to start a revolution, even though they may not have known it then.
What do you mean? Who?
Three scientists at Bell Laboratories, John Bardeen, Walter Brattain, and William Shockley. They invented the transistor, a tiny little device that would change the world forever.
Transistors? Aren't they just in radios and hearing aids? I mean, where's the revolution?
That's what most people think, but the truth is that the invention of the transistor and the semiconductor industry it launched may be the most significant event in modern history.
Really?
Absolutely. Shockley went on to improve the original transistor with his junction transistor. He returned to his native California in 1955 and started Shockley Semiconductor in Palo Alto.
Ah, the beginning of Silicon Valley.
In a way, yes. Shockley recruited the brightest engineers and scientists to improve the transistor. Then in 1957, 8 of his top employees left to form their own firm.
Starting Fairchild was a bit of a fluke for the 8 of us. We had originally planned on going out and looking for jobs individually, and then maybe finding a company that would like to hire us all together. It was only when we caught up with Arthur Rock and Bud Coyle, who worked for Hayden Stone, the investment banking firm, that they suggested that we ought to set up our own company. Since that let us continue to live in the houses and we had already purchased and work in the same area, we thought that was a great deal. We had no idea at all that starting a company was going to be the first step in the Silicon Valley phenomenon.
Gordon Moore, Robert Noyce, Julius Blank, Victor Greenwich, John Hornet, Gene Kleiner, Jay Last, and Sheldon Roberts started Fairchild Semiconductor. Soon after that, Jean Hornet of Fairchild developed the planar process, and planar transistors set the stage for the integrated circuits that followed. The revolution was underway, but I'm getting ahead of myself. Jack Kilby of Texas Instruments and Bob Noyce of Fairchild, within months of each other, at the end of 1958 and the beginning of 1959, invented the integrated circuit. The first ICs had only a few transistors connected on a single chip of silicon, but they started a chain reaction that continues to drive the semiconductor industry today. The race was on to put more and more transistors on smaller, more powerful chips.
I wonder if they realized the significance of their inventions.
I thought it would be important for electronics as we knew it at that time. What I didn't appreciate was how much the field of electronics would expand.
I don't think anyone ever knows how significant their contributions will be at the time, but the technical evolution of integrated circuits ultimately led to many entrepreneurial ventures. Ultimately, venture capital flowed into the still small semiconductor industry, and new startups began to drive progress in the industry.
The thing I've always emphasized in making my investments is people, and I've tried to figure out whether people are highly motivated and whether they are intellectually honest. And by intellectually honest, I mean, can they see things as they are instead of the way they wish they would be? And I've had great success doing that.
Fairchild itself was the launching pad for hundreds of new spin-offs. Charlie Sporck left Fairchild to open National Semiconductor's operation in Sunnyvale. A year later, in 1968, Noyce, Moore, Andy Grove, and several others left to form Intel. The year after that, Jerry Sanders and others from Fairchild left to start AMD. This was only the beginning of the proliferation that led to the renaming of Santa Clara County as Silicon Valley. The next major semiconductor innovation appeared at Intel in 1971. Ted Hoff, Federico Fagin, and Stanley Mazer developed the first microprocessor. The Intel 4004 contained 2,300 transistors and was designed for Masatoshi Shima of Visicom for a line of handheld calculators. The 4004 had computing power greater than the world's first computer ENIAC, introduced in 1946, which occupied an entire large room. Imagine replacing a computer that occupied one large room with a tiny microprocessor. This first microprocessor became the building block for future technological developments, including Intel's 8088. It contained 29,000 transistors, but even more significantly, it was selected by IBM in 1980 as the CPU of its personal computer. This launched the PC revolution, which really changed our lives, but it also created tremendous growth for the semiconductor industry.
Well, to me, the most important thing about the microprocessor has been the fact that we took it away, we took the computer away from these elite forces that used to control it, and we made it available to everybody.
In 1965, while at Fairchild, Gordon Moore predicted that microchips would double in density every 18 to 24 months. Moore's law has turned out to be remarkably consistent since then, and in 20 years, if Moore's law continues, computer chips will be billions of times more powerful than they are today.
That's hard to imagine.
So is this. Every month, 4 quadrillion transistors are produced, more than 500,000 for every person on the planet. The global chip industry is valued at more than $140 billion today. And as it continues to grow and produce even more powerful chips, we'll find many more ways to use them. They've become an integral part of our lives, influencing the way we work, study, play, and live.
Right, like in the medical field.
Yes, the medical field has advanced rapidly because of these tiny chips.
And science has benefited greatly, too.
Right?
And education.
Absolutely.
And business.
Yes.
And entertainment.
Everything.
Good evening. I'm Sandy Robertson, and on behalf of our firm, the Bank of America, the other sponsors and supporters of tonight's benefit for the Tech Museum of Innovation, I would like to welcome you and thank you for being here. 50 years ago last month, 3 researchers at the Bell Labs in Murray Hill, New Jersey, were searching for a solid material replacement for the unreliable vacuum tubes used to amplify electrical signals. One rainy Tuesday on December 16th, 1947, one of them connected 2 strips of gold foil to a 1/2-inch long, thin piece of germanium. To their amazement of their colleagues, they showed that electrical power coming out of that piece of germanium was 100 times stronger than what went in. On that day, 50 years ago, the transistor was born. The concept of semiconductors was launched, and the world was changed. In the train of human history, there have been a handful of seminal inventions: the wheel, the steam engine, the automobile, the telephone, and the transistor. John Bardeen had it right when he said on the 25th anniversary of the semiconductor in 1972, quote, "It has gone a great deal further than I could have imagined at that time." How prophetic those words sound today. The semiconductor industry is the basic industry of the information age, just as the steel industry was basic to the industrial age. The chip has truly altered the way the world works. Tonight we're here to celebrate and honor those who have helped change the world. The 3 scientists in whose lab that first transistor was made, and the leaders in science, in technology, and in business who helped turn that first transistor into the most powerful force of change in this century. At Robertson Stephens, we've been fortunate to be a part of that revolution, and I'd now like to introduce another partner in that revolution. Ladies and gentlemen, the chairman of Bank of America, David Calder.
Thank you, Sandy, and thank you, ladies and gentlemen. It took 9 years for the Nobel Committee to recognize the importance of what happened at Bell Labs, and it did so by awarding 3 men the Nobel Prize in 1956. Our first awards tonight recognize these 3 men. John Bardeen was a research physicist at Bell Labs from 1945 to 1951. He is one of the few people in the world to have won the Nobel Prize twice, once for the transistor and once for his work in the area of superconductivity. Walter Brattain, our second honoree, worked at Bell Labs for almost 40 years, from 1929 to 1967. He also did pioneering work on the magnetic detection of submarines for our National Research Defense Apparatus during the Second World War. And William Shockley was Bardeen and Brattain's supervisor, who helped improve on their invention just 1 month later when he conceived the junction transistor, a device made of silicon. It was Shockley who came in 1955 to his native California, setting up Shockley's Semiconductor right on San Antonio Road, the original home of the Fairchild 8. In a sense, it was Shockley who brought the silicon to Silicon Valley. We honor all 3 of these pioneers tonight. Sandy?
And here to accept the award on behalf of those 3 Nobel laureates is Mark Pinto. Mark is the Chief Technology Officer and Vice President of Lucent Technologies Microelectronics Group, the progeny of Bell Labs and the organization which houses it today. He was a Bell Labs Fellow in 1955. Dr. Pinto is a child of the transistor age, and today he is helping lead an organization bringing its wonders to the next generation. Dr. Mark Pinto.
Well, thank you very much. I'm delighted and deeply proud to accept this award on behalf of John Bardeen, Walter Brattain, William Shockley, and also Bell Laboratories. Every day, miracles are being carried out by an estimated 200 million transistors in the world. In fact, there are now more transistors produced per person in the world than the average amount of calories that people consume. I think I want to start actually by thanking one of the people who wasn't really one of the inventors and yet deserves a lot of the credit. His name was Mervyn Kelly. He was a director of research at Bell Labs, and he was the one who envisioned the need for a rapidly growing telecommunications infrastructure after World War II. He established the Semiconductor project in 1945 in an attempt to address the performance roadblocks imposed by electromechanical relays and vacuum tube amplifiers. So it really was his vision. The key breakthrough was made by John Bardeen. He had a new theory to explain the lack of modulation in 3-terminal germanium structures. And following this path, he and Walter Brattain were the first to demonstrate the transistor effect in December of 1947. Using that famous slab of germanium, the razor-cut strip of thin foil glued to the spring-loaded wedge of plastic. Bardeen was known as Whispering John. As you heard, he was a relatively new Bell Labs employee. He was a brilliant theorist, and he came across as very shy, very self-absorbed, and as you heard, he won a second Nobel Prize for the theory of superconductivity. Brattain was more senior. He was extremely extroverted, and he was a resourceful experimentalist. Ever outspoken, Brattain was to lament later in life, and I quote, "The only regret I have about the transistor is its use for rock and roll." And what of William Shockley, the brilliant mercurial graduate of Hollywood High School, then later Caltech and MIT? He's known as a fierce competitor. There's a story at Bell Labs. He got into such an argument over a fine point of physics that he took a younger colleague and tossed him out of his racing car in the middle of New Jersey and left him there in the rain. But Shockley was one of the leaders of that project, and he was really somewhat frustrated with himself for not having personally played a greater role. But he did make up for it real quick. 1 month after the invention, he had completed a thorough formulation of p-n junction theory and minority carriers that was verified experimentally a month later, and that led to the invention of the junction transistor. Mervyn Kelly realized that the transistor was an important breakthrough and that keeping that technology under wraps was a self-defeating policy. Many scientific disciplines converged in that tiny, simple device, advancing communications for the next century. Moreover, the capability that produced the transistor breakthrough also led to much work in materials processing, electronics technology, that made possible the subsequent inventions such as the integrated circuit and the microprocessor. So again, on behalf of the inventors of the transistor and on behalf of Bell Labs, let me thank you very much for this great honor. Thanks again and have a good evening.
Okay, ladies and gentlemen, awardees, guests, movers and shakers, supporters of the tech, children of the chip, and fellow introverts. I trust that all of you have been served and not overserved. It's showtime. By the way, Federico Fagin told me at the table, and you might check this out if you have your dessert, it's not state-of-the-art because it's only a 3-inch wafer. But nonetheless, enjoy it. My name is Fred Hoar, and I'm privileged to be your MC. A wise man said the secret of life is being in the right room. This is definitely it. Do you know how many people we have? This started out as a small, intimate dinner party of about 12, and we now have 1,000 people. So let's give a round of applause for the producers. Today we live in a maelstrom of existential change, much of which began with the transistor. Consider that Tom Watson at IBM in 1943 said, "I think there's a world market for perhaps 5 computers." Bill Gates in 1981 said, "I think 640K ought to be enough for anybody." Ken Olsen at Digital said in 1975 he could see no reason why anybody would want a computer in their home. And I'm not sure this relates, but I liked it. H.M. Warner of Warner Brothers said in 1927, "Who the hell wants to hear actors talk?" And he had a point. But you can run, but you can't hide from the chip. It's the basis of the productivity boom which has led to this amazing era of plenty. If America in the first half of the century was pumping iron, in the second half it's been pumping silicon. Also, our valley has seen itself replicated and cloned. Imitation is the sincerest form of flattery, but it's kind of a silicon diaspora. Silicon Island, Silicon Forest, Silicon Mountain, Silicon Prairie, Silicon Desert, Silicon Alley in New York, now a Silicon Fen in Cambridge, England. We ought to charge a licensing fee. The Tech Museum of Innovation is capturing all the stories about what this has meant to the planet and to the people on it. And the Silicon Valley, as some have said, is the triumph of hope over experience. It's also the ascendancy of intellect of the Fairchild 8. 6 were PhD. Of our 25 awardees tonight, 20 have PhDs. The other 5 probably made more money, but there you are. We've now entered the 6th semiconductor decade, the 5th mainframe decade, the 4th of the mini computer, the 3rd of the desktop, the 2nd of the laptop, and the 1st decade of the internet. And it's all part of the acceleration of history since the transistor. And it gives me great pleasure to introduce an individual who's been fighting the odds almost single-handedly to put on this extravaganza, our impresario and event leader who is himself a PhD. He's been in the industry for 30 years. First at TI, then at DataQuest, and for 15 years on Wall Street, and he has the scars to prove it. He's the managing director of BARS, and he's also a senior semiconductor analyst. Would you please welcome our host, Dan Klesken.
Good evening. In 1957, Julius Blanc, Victor Greenwich, Jean Hornet, Eugene Kleiner, and Jay Last, Gordon Moore, Robert Noyce, and Sheldon Roberts all resigned simultaneously from Shockley Semiconductor. They had hoped that another company might hire their group as a group, but that was not to be. Arthur Rock, with Hayden Stone, a major brokerage house in New York, met them as a favor to Eugene Kleiner's father. He told them that he could find jobs for them, but that maybe they should really form a company. The idea was appealing to them, and they agreed that if Arthur Rock could arrange the financing, they'd do it. But that was really the tough part. Arthur struck out with the first 35 potential investors, but finally Sherman Fairchild agreed to back the operation. And that started the venture capital business, and Fairchild Semiconductor was born in 1957. We really can't say enough about the impact that Fairchild Semiconductor has had upon the industry and the Valley. Among Fairchild's contributions are the planar process, the integrated circuit itself, linear circuits, an incredible number of new technologies, products, and so many industry startups that frankly, we've lost count. Tonight, we're very pleased to honor the 8 founders of Fairchild Semiconductor with this 50th anniversary award. Please join me now in welcoming the following living founders of Fairchild Semiconductor. Mr. Julius Blanc, Victor Greenidge, Eugene Kleiner, Jay Last, and finally Sheldon Roberts. Accepting the award for Jean Hernay, who is deceased, is Charlie Sporck. For Gordon Moore, who can't be with us this evening, but certainly well alive, but unavailable tonight, is Craig Barrett. And finally, accepting for Bob Noyce is his brother, Don Noyce. Will they please come forward, please? We're very delighted to have been able to tape the remarks of Gordon Moore and his thoughts about Fairchild, the founding of the company in the early days. Now I'd like to share that video with you.
Well, you know, a recent issue of Physics Today, the magazine of the American Physical Society, described Shockley as the Moses of Silicon Valley. And I think maybe that's a pretty good description. Shockley brought silicon to Silicon Valley. He also brought many of us into the industry that may not have been here otherwise. I certainly owe him a real debt for getting me into this exciting business, and probably also for propelling me on to be one of the founders of Fairchild. Well, it was an accident that we were entrepreneurs and set up Fairchild. If we hadn't caught up with Art Rock and Bud Coyle, I don't think any of us would have had the idea of setting up our own company. That wasn't something that was normally done in those days. There was essentially no venture capital industry, certainly none that focused on companies like they do today. But I think in a real respect, Fairchild was the beginning of the Silicon Valley phenomenon that we've all grown to appreciate, and it has been so important in bringing new technology to the marketplace. This is an industry where it really requires risk to be successful. I don't know of an approach that's really safe, that can move at the rate that technology does. As an example of the kind of risk you have to take, this year, well over 80% of Intel sales, that's over $20 billion in revenue, will come from products that weren't introduced as of January 1st of 1997. I can't imagine another industry where change is that rapid. Well, we certainly have been blessed in Silicon Valley by having a great group of people. I think the ones that Shockley brought in initially, my colleagues in founding Fairchild, certainly have demonstrated that. And over the years, the people that have come in at Fairchild and Intel, the other companies in the Valley, have certainly kept it moving along and have maintained leadership in the industry in this area. I think that's a tremendous accomplishment and says a lot for the quality of the people and their dedication.
Within months of each other, in September of 1958 and early 1959, Jack Kilby of Texas Instruments and Bob Noyce of Fairchild Semiconductor independently developed the integrated circuit, several thousand transistors interconnected on a single chip of silicon. This breakthrough set into action a chain reaction that continues to drive the semiconductor industry today, the constant pressure to put more and more transistors on a smaller, more powerful, and less expensive chip. Jack Kilby of TI was responsible for all of the integrated circuit development at Texas Instruments from 1958 to 1970. Within a year of joining Texas Instruments, he invented the monolithic integrated circuit, one of the major milestones of the semiconductor industry. In 1970, Mr. Kilby began a leave of absence from TI to work as an independent inventor, and today is employed as an independent consultant. He has served as the chairman of the Department of Defense Advisory Group on Electron Devices from 1980 to 1995. He was a distinguished professor of electrical engineering at Texas A&M on a part-time basis from 78 to 84. And he currently serves as a director of Wiley Laboratories, Benchmark Electronics, and Research Applications Incorporated. Recognition of Jack's many accomplishments include the National Medal of Science, the National Medal of Technology, and the introduction into the National Inventors Hall of Fame. We're delighted that Jack can be with us tonight to accept this 50th anniversary award for his outstanding contributions to the industry and our world. And now I'd like to introduce Mr. Jack Kilby. Bob Noyce was an inventor, a creator, an innovator, and an inspirer to many people around him. Bob was a capable leader, a founder of Fairchild Semiconductor, a founder of Intel Corporation, and a businessman par excellence. He had very many successful investments. He was a creator of innovation. And then toward the end of his career, he was the president and chief executive of Semitech. Bob was an articulate spokesman for the industry, but beyond his public stature, he was also an avid skier and an excellent swimmer. He was the semiconductor industry's true Renaissance man. The 50th anniversary award that we present to Bob Noyce tonight honors the invention of the first integrated circuit, but it's also dedicated to the entire body of work that Bob Noyce brought to the semiconductor industry, and it's for this lasting influence on us all. Now, accepting tonight for Bob Noyce is his brother Don Noyce, who's a professor at Berkeley. He taught chemistry at Berkeley for over 40 years. Would Don Noyce please come forward?
It's a privilege to represent my brother, and I know that his widow regrets that she cannot be here this evening. When he was young, when he was about 14, he and my brother Gaylord set out to build a glider that they could fly in. So they assembled some sticks and some cheesecloth, and they put it together, and they took it up on the garage, and my mother's hair turned gray. In 1947, my brother was a junior in college, and he was practicing diving. And that year, he succeeded in winning the Midwestern Conference Diving Championship. He was a man who always liked to succeed and be the best. Several weeks ago, one of the elderly gentlemen in the condo where we live, I think he's 95 now, said that his broker some years ago had said he really must buy some Intel. So he bought some Intel. And he said, well, it made me a wealthy man, but Don, can you tell me, what does Intel do? Thank you.
It's my great pleasure now to give the next 50th anniversary award. It's also to one of the members of the original Fairchild 8. It's to Dr. Jean Horny for the invention of the planarization process. There were 20 employees when Dr. Horny joined Shockley Semiconductor in the Palo Alto in the mid-1950s. He left in 1957 to found Fairchild Semiconductor with the 7 other Shockley employees, and the rest, as we know, is Silicon Valley history. In 1959, Dr. Orny received a patent for the planar process, one of the most important developments in the semiconductor industry. It was integral to the development and production of Bob Noyce's first integrated circuit and to the many integrated circuits we take for granted today. Although Dr. Orny is being given an award for his brilliant technical achievements, he was also a very astute businessman. After leaving Fairchild, he founded both Amelco Semiconductor and Intercell. Accepting the award for Dr. Orny is his close friend, Dr. Jay Last, also one of the members of the original Fairchild 8. At Fairchild, he too worked on developing the first commercial silicon planar transistors, and he later ran the research and development group that produced the first integrated circuit chips. Dr. Last.
It's with great honor I accept this on behalf of John, and it's with great sadness that he's not here to accept it in person.
It's my honor to present the next award. It goes to Bob Weidlar and Dave Talbert. Bob Weidlar was known as a circuit genius when he joined Fairchild. They're both employees of Fairchild. His process man and partner, Dave Weidlar, Dave Talbert, both achieved worldwide recognition for essentially originating the linear IC business. Bob joined Fairchild's application engineering department in the early 1960s, where he designed the first successfully marketed linear integrated circuits, the 702 and the 709, both for operational amplifiers. Fairchild's linear ICs were a set of compatible building blocks for use individually or in tandem in a wide range of applications. They offered advantages in cost, speed, size, and reliability, really all metrics that are very important still today. When he moved to National Semiconductor, the analog circuits he designed shifted the leadership position in analog from Fairchild to National. Our equivalent of Michael Jordan, Bob truly dominated the analog integrated circuit design field from 1964 well into the 1970s. Dave Talbert joined Fairchild in 1958, working closely with Bob. He defined the processes, the unique processes that were specially tailored to accommodate Weidlar's design objectives. His ability to tailor those processes made his contribution truly exceptional, both to Fairchild and later to National. Here to accept the awards on behalf of these two exceptional talents is a man who knew them well, Fairchild's general manager, National CEO and director, a legend in the industry himself, Charlie Sporck.
I was planning on telling you a number of anecdotes about the early days, but I'm told I have 2 minutes, so I'm down to 1. And I've picked the one that has to do with the early days of Fairchild's marketing organization. In the early days of Fairchild, being the 60s, they had the most powerful marketing organization in the industry. The people who were all together in one organization who in subsequent years went off and indeed either founded companies or founded organizations. This has to do with one of these people, Jerry Sanders, which I didn't mention earlier, which is difficult to avoid. But I can embellish on this story tonight because he's not here. These were very young guys, very intelligent, very gung-ho, very cocky, and this story has to do with that. This was about the period of 1964-65, and Sherman Fairchild was out in the West Coast for some event that was going on at Stanford. And he and Dick Hodgson, who was a vice president at Fairchild at the time, and Bob Noyce, after this ceremony, was having dinner at L'Auberge in Atherton. While they're sitting down, in comes Jerry Sanders with 2 guys young fellows, engineers from IBM. And one of either Hodgson or Bob noticed them, and he waved them over and he said, "Come on over and join us." So they come over, and you understand these were the days where IBM was a white shirt and in a dark suit and very proper decor. So they come over and they're introduced, and one of the people they're introduced to is Sherman Fairchild, the chairman of the executive committee of the board of IBM. Well, that drew their attention. They sit down, and with this, Jerry looks across at Sherman and says, "Sherm, I think we're dating the same girl." And Sherman says, "These two IBM guys, are trying to disappear." And Sherman says, "Is that right? Who is she?" She says, "Oh, it's Marjorie out there at the Republic Aviation." You understand, at this time, Jerry was single, and he was Jerry. Sherman Fairchild says, "Is that right? At what's her name again?" It's Marjorie. So he reaches in his pocket, and he takes out this black book, and he goes, "Stuart," and he says, "Oh, yes, I think we are." And the funniest part of this thing is you got to imagine these two IBM guys going back to IBM, and they're trying to think of themselves now, who's selling who here? Who do we give this order to?
Dr. Gordon Moore, a founder of both Fairchild Semiconductor and the Intel Corporation, observed in early 1965 that integrated circuits would double in density every 18 to 24 months, and that this rapid progress would also create a steady decline in the cost of these microchips. We have come to know this phenomenon as Moore's Law. The award I'm about to present is for his discovery of Moore's Law and for how it has enabled companies around the world to plan their future products and shape their business strategies. Since Dr. Moore couldn't be with us here tonight, we have a brief video from both Gordon Moore and Andy Grove about Moore's Law.
Given that integration has been the basis of how the semiconductor industry operates, the formula, if you wish, that defined integration for us was Moore's Law. Gordon Moore, some decades ago, observed that when he plotted transistor count as a function of time on a semi-log plot, he got a straight line. And he started using that straight line to extrapolate what will be possible in the future. And the rest of us have scurried around trying to make his predictions come true. That has kind of been the way this industry has worked. And there is every reason to believe that Moore's Law and the integration that it projects will continue in the years to come.
Well, Moore's Law, first of all, comes in so many versions, one of them has to be right. But secondly, has kind of changed from something that was chronicling what happened in the industry to something that's driving the industry. Companies now realize that if they don't make progress at the rate that these exponential rates of progress show, they're going to fall behind. So companies put their programs together to either stay on the trends or even to get ahead of them. And in that respect, it's kind of a self-fulfilling prophecy now.
Well, the next award is to Dr. Robert Dennard, who's receiving this 50th anniversary award for his invention of the dynamic RAM memory cell used in most computers today. In 1978, a leading-edge 16 kilobit DRAM could hold half a page of typed text. Today's 64 megabit DRAMs can hold over 3,500 pages. And given the pleasure I have had over the last couple of years covering the DRAM industry, I wasn't sure whether giving him an award or shooting him was more appropriate. I was outvoted. Anyway, Dr. Dennard is currently an IBM Fellow at the IBM Thomas J. Watson Research Center in Yorktown Heights, New York, where he has been involved in microelectronics research and development from its early days. In addition to his 1967 invention of the DRAM memory cell, he also worked with others to develop the concept of FET scaling in the early 70s. Among his many awards and achievements, Dr. Dennard received the National Medal of Technology from President Reagan in 1988, and he was inducted into the National Inventors Hall of Fame in 1997. It is my pleasure to present this award to Dr. Robert Dennard.
Thank you very much. I'm very grateful for this honor and happy to join in the celebration of the 50th year of the transistor. When I was in college in the early 50s, we only studied vacuum tubes, and I saw transistors for the first time in graduate school when my dean brought home a few from his sabbatical at Bell Labs. And they were the point contact kind, and they didn't really behave very well. I think I burned out quite a few of those early varieties. So I didn't learn much about transistors until I was lucky enough to join a microelectronics project at IBM Research in the mid-60s. And like other companies, IBM was trying to improve field effect transistors or MOS transistors and to learn how to use them in integrated circuits for computing purposes. And my boss gave me the assignment to find the best way to do memory in this new technology. We had a way to do it, but it used 6 transistors for every bit. And at that time, all computers used magnetic cores for memory. And one day I heard a talk by another research group which was telling about how they were really going to extend that technology. And I was very impressed with their approach and how simple it was compared to our 6-transistor approach. So I went home that evening and I started thinking of a better way. And after some time, I thought about storing data as by storing charge or presence or absence of charge on a capacitor. A tiny capacitor was easy to implement in our MOS technology, and I could use transistors to steer the data in and out of these capacitors. So I got very excited, and I called up my boss that evening, that night really, by that time, and I told him I'd really found the way to revolutionize computer memory. And he essentially told me to take 2 aspirin and call him in the morning. Actually, it took me a couple more months to realize that only a single transistor was needed in each memory cell to write the data in and read the data out. And our patent on this was issued in 1968. Well, within a few years, Intel built the first commercially successful DRAM chip using the same principles with 3 transistors in each cell. And the following generations of DRAM have all used this 1-transistor approach. And so from thousands of bits per silicon chip at that time, we've gone to 64 million bits per chip today. And this kind of progress has only been possible because thousands of people have made substantial contributions to better materials, better processes, and designs. And I want to thank IBM for its support of research and development, my associates for helping me learn all about how transistors work, and my thousands of colleagues in microelectronics throughout the world. So I think together we've truly changed the world of computing. Thank you.
The third major milestone in the semiconductor innovation occurred in 1971 when Intel introduced its 4004 microprocessor, which contained 2,300 transistors. That device was the foundation for the explosion in the chip technology that has reverberated to many products and applications. In 1971, Ted Hoff, still fresh from postgraduate work at Stanford University, conceived the first microprocessor at Intel, and the talented team of Stanley Maser and Italian-born physicist Federico Faggin carried through with its development. Hoff's 4-chip set centered around one general-purpose logic device that could access its application instructions from the semiconductor memory, and that replaced 12 custom chips in a programmable calculator, and it could be adapted by programs to perform many different applications. It packed as much computing power in that tiny chip as the first electronic computer, the ENIAC, which filled a warehouse when it was built in 1946. We've come a long way in 25 years, and that was just the beginning of things to come. Accepting for the team of Hoff, Maser, and Faggin now is Ted Hoff. Will each of the 3 recipients come forward, please, to accept their awards?
Thank you so much. It's hard to believe it's been so many years since we first produced that product. In fact, I've often been asked, what were the most difficult aspects of that project? And probably the most difficult was persuading our marketing people at Intel that it was worthwhile to offer it as a product. It's hard to believe these days. And in fact, I had one marketing manager who took me aside and he said, look, the mini computer people have already started this business and they've got a good position in it. We're late. If we're lucky, we might get 10% of the business. Now, they sell 20,000 mini computers a year. That means if we're lucky, we'll do 2,000 chips a year. And for 2,000 chips a year, it just isn't worth the hassle of offering this complicated a project. Well, I have the greatest respect for marketing people, and I've worked with them a lot. In fact, I've learned a great deal, probably more from marketing people than I learned in college. But I'm very grateful that this one time they were wrong in their projection. Thank you.
It's now fitting that this next 50th anniversary award is presented to Dr. Masatoshi Shima, president of TOPS Corporation in Japan. While with Busicom Corporation of Japan during the 1960s, Dr. Shima developed the desktop calculator, introducing ROM-based stored programming technology with decimal plus binary computer architecture. Now, Dr. Shima worked with Intel on the development of its first microprocessor, the 4004, designing its logic in a desire to use it in his calculator. He continued to work as a customer with Intel on the development of the new microprocessors until he joined the company in 1972. He later moved to Zilog as manager of the high-end microprocessor group, where he developed the Z80, the Z8000, and their peripheral chips. His role in the development of the first microprocessor cannot be underestimated. Therefore, it gives great pleasure for me to introduce Dr. Masatoshi Shima and to give him this award.
Thank you very much. It is a great honor for me to be here and receive the award as the 50th anniversary of Silicon Chip. From a personal viewpoint, this prize reinforces the pride and satisfaction I take in having spent the last 29 years on the development of microprocessor. 30 years ago, in 1968, 1 year before the birth of microprocessor at Busicom Corporations, I developed the desktop calculators utilizing stored programming architectures with read-only memory and decimal computers. Next, in June 1969, I came to here to develop LSI to be used for not only desktop calculator, but also the office equipment. Busicom chose the Intel Corporation because their management and advanced technology. But unfortunately, there was only one thing which I've never expected. Due to lack of logic engineer at Intel, I have to design the microprocessor's logic by myself. I have been wishing that if we worked together beyond the nation, human race, and companies, new generations, breakthrough technologies to open new world will come out soon. Many thanks to all of you. Thank you.
It gives me great pleasure to make this next 50th anniversary award to Dr. James Kim, Dr. James Joo-Jin Kim, who is the chairman of Amcor, for his contributions to the semiconductor industry's merchant supplier-based packaging industry. Jim has been a leader in this industry since joining his father in the late 60s in the business after leaving his professorship of economics at Villanova University. Jim has a PhD in economics and has used his business acumen developing the merchant packaging industry, founding Amcor Electronics here in the United States, in building a worldwide business for Amcor and Anam, and presenting to the industry a very capable merchant packaging capability. It's with great pleasure that I present this award to Dr. James Kim.
Thank you very much, Dan, for kind introduction. Ladies and gentlemen, honored guests, I'm very honored to be among such a distinguished group of industry giants. In 1968, when my father, Hyang-Soo Kim, and I started in the assembly business, today it's called the packaging, no one dreamed that Amcor Technology would be a $1.5 billion company participating in the $150 billion semiconductor industry today. Do you remember BOMA? Some of you may remember. I remember the early 1970s when BOMA had the first handheld digital LED calculators. Some of you will remember that to make those calculators, you need LEDs, and each LED has to be aligned perfectly linear. Otherwise, all those digits are up and sort of not linear at the time. It's very difficult to use the calculator. Anyway, that business affected the fortunes of many companies and individuals. The rest is, of course, history. We came up with how to align those LED displays so the numbers looked linear. I say looked linear because it depends on how you inspect them, by the way. I am truly honored to receive this award. Thank you very much.
A letter from Joo-Jin Kleiner to his father reached Arthur Rock in the corporate department of Hayden Stone, some of us may remember. And he and his senior partner, Alfred Coyle, flew across the country to meet with Kleiner and 7 other Shockley scientists. The group hoped to find a company would hire them, but were unsuccessful. And getting money to start their own company wasn't easy because the multi-billion-dollar venture capital industry that we know today did not exist, of course, at that point. Rock, in his wisdom, thought that they should go into business together, so he put them in touch with Sherman Fairchild. Fairchild Semiconductor was the result, and that company was founded in 1957. Arthur Rock ultimately led the way for the rapid growth of venture capital in the semiconductor industry, and he has been involved with the funding of numerous companies along the way. In 1968, he became involved again with Fairchild co-founder Bob Noyce as a co-founder and as the first chairman of Intel. When Rock moved to California, he formed the venture capital firm Davis & Rock. He now runs Arthur Rock & Company based in San Francisco. He is honored tonight for his vision and for his pioneering role in the venture capital community, which has made the semiconductor industry, in terms of its financing, what it is today. Arthur Rock cannot be with us tonight, but will share some of his remembrances with us in this video.
Well, when Tommy Davis and I started the firm of Davis & Rock in 1961, there was no organized venture capital, and institutions were very loath to invest in high-risk ventures. At that time, institutions took the prudent man rule and felt that they shouldn't take undue risks. So we had to raise all of the capital we needed from individuals. We raised the princely sum, or at least now seems like the princely sum, of $5 million. That money was not all spent. We only spent about $3 million of it because we got so involved in our investments that we didn't have time to look for new investments. One thing that might be of interest to this audience is that when I was involved in the financing for Intel Corporation in 1968, the president of one of the magnetic core companies called me to tell me what a mistake I was making. All memories for computers were made out of magnetic cores, which were, of course, all strung by by people. If the computer industry developed the way it has using magnetic cores, it would take more than, probably take more than the world's population to string those cores. On the other hand, we probably wouldn't have had the great explosive growth in computers that we have today without semiconductor memories. I haven't really spoken to that man since. He's never bothered to call and tell me what happened.
Regis McKenna is the chairman of the McKenna Group in Palo Alto. He lectures and conducts seminars on technology marketing and competitiveness throughout the world, and has worked with more than 300 startups, including Intel, Apple, Microsoft, Silicon Graphics, Genentech, and on and on. A widely read author, he is known as the marketing guru of Silicon Valley. Welcome, please, Regis McKenna.
I was given 3 minutes, and I thought I've been around the semiconductor industry for 30 years. That's roughly about 35 years, actually, so that's really 10 years per minute, but that's about the speed with which this industry has moved. And I just want to say a few things, but I was thinking along one line, and then sitting here watching these wonderful people come up here and talk, I really changed my mind. When we look back from the past or in the future and look at the past and look at the history of the transistor and this whole history of Silicon Valley, we're not going to really, we're going to see it sort of pristine, we're going to see it abstracted from the reality. And the reality is that it's a bunch of people. And so people make mistakes, people are champions, people are leaders, people are filled with different kinds of characters. And an example of this may have come tonight when Dave Talbert and Bob Weidler were given an award. But if you had known the two of them, it would have been quite different than what you heard. Bob Weidler was crazy. I mean, he, just in a little anecdote, we went over one time, he kept an axe in his office. And he worked better when he was not sober. And he would often disappear for months at a time, and no one would know where he went. One time I brought in a graphic artist who was preparing his data sheets, and I brought him over to see Bob because this fellow wouldn't go in the office with him alone. And it was after lunch, so Bob was feeling well. And he couldn't get the staple out of the data sheet, so he put it on his desk, and he went over to the corner and picked this axe up. And he struck it in the middle in the desk, and the fellow disappeared. I never saw him again. And Bob used to tell me that he would go up into the hills here. He loved to shoot guns off up in the hills, and that he had a can up there with my name on it, and that. Also, Dave Talbert, I remember one time that I was late for a meeting, which I was always late for in all meetings, and I came back, and Don Valentine was asking me whom I worked for, where I was, and I said, well, I was over for the last hour or two talking to Dave Talbert, and Don said, I don't believe you. Dave Talbert's never said more than 2 words to anybody in his life. Very quiet, but very effective individual. So, but what struck me is that the 8 people who started this industry were known as the Traitorous 8. They were the rebels. They were entrepreneurs in the true sense. And you know, it wasn't Terman who started Silicon Valley. It was really the people who left Shockley who created an egalitarian environment. In fact, Gordon Moore likes to say that if it weren't for the irascible and the negative demeanor of Shockley, this industry, this whole valley would never have gotten started. So the history of this industry is really colorful. One of the first applications of the microprocessor, the 4004, was flushing banks of toilets. You know, they all had to flush it at once, and I mean, there was strange things that would, any kind of application would begin to grow, but there were people who drove this industry, who put in long hours, long efforts, personal sacrifices, family sacrifices, and they made this industry really what it is, and the characters, and I think probably none other represents the characters of this industry more than Bob Noyce. And I think that we somehow or other have to keep that character alive if we're going to not just create a lot of independent entrepreneurs out to get wealthy, but people who are going to sustain Silicon Valley and the growth of the transistor in its modern form. Thank you.
Good evening. It gives me great pleasure to have the opportunity to introduce to you one of the true luminaries in the capital equipment, semiconductor capital equipment industry, Dr. Dan Maydan, President of Applied Materials. When Dan Maydan came to Applied Materials in 1980, it was in many ways a tremendous career gamble for the Bell Labs scientist and project leader. At that time, Applied Materials was a rather small company in an industry known for its fast-paced, constantly changing technology. Dr. Maydan, on the other hand, was already a shining star in the world of scientific research at Bell Labs. Nevertheless, he leapt. And since then, he has successfully made the transition from research scientist to industry technology visionary to business head of a large, intensely technical global corporation. Certainly something that only a handful of leaders have achieved. Along the way, he managed to remain a scientist, despite the ever-changing nature of the semiconductor industry in general. This is certainly not the first award that Dr. Maydan has won, and I'm sure it's not the last. Tonight, we honor Dr. Dan Maydan of Applied Materials with this 50th anniversary award for his contribution to the semiconductor equipment industry in general and to plasma etch technology in particular. Dr. Dan Maydan.
Ladies and gentlemen, it's a great honor for me to accept this award. You know, in the good old days, when I used to spend my days and few of the nights at Bell Labs, people used to count the number of good transistors per wafer. Today, it's even very difficult to, with everything coming smaller and smaller, equipment getting better and better and better process, it's very difficult even to count the number of good dies per wafer. So with great honor, on behalf of all Applied Material employees, every place in the world, I accept this award. Thank you very much.
While semiconductor-driven products have become ubiquitous in our lives, and Intel has established the microprocessor as a consumer product, including dancing models in bunny suits, which suddenly have a new historic meaning to me, I might add, parading regularly in television advertisements, the semiconductor equipment industry remains an often little seen but vital portion of the entire semiconductor industry. If the industry represents, the semiconductor equipment industry represents the engines under the hood, then the engine with the most horsepower is surely Applied Materials. Jim Morgan has been the CEO of Applied since 1977 and has served not only as a leader of Applied, but in fact as a spokesman for the entire industry. In 1996, adding to his many distinctions and awards, Jim was awarded the Medal of Technology by the President of the United States for his industry leadership and for his vision in building Applied Materials into the world's leading semiconductor equipment company. It is my pleasure to introduce Jim Morgan.
Thanks, Sue. Of course, usually what the question is what do the equipment and materials companies do? Those of you here, of course, know that, but the general population, it's always a mystery. In the 60s, I was camped outside Les Hogan's door, and I was trying to get a few devices in order to build the radar homing warning systems that Dalmo Victor needed to supply the Air Force. Now, you couldn't believe from that struggling period that we would have an industry that we have today. Because you got very few devices, the yield was unpredictable, the quantity you would get was unpredictable, and the quality was unpredictable. Other than that, it was a very perfect side of an industry. Now, if you look at how the industry has transitioned to where really the semiconductor is the driver of the information age. And when I became president of Applied Materials in 1976, most of my friends thought I was crazy. After I was there about a month, I kind of began to think that might have been true. We were about to go bankrupt, but what I found as I went out and visited some of the customers, and some of you here I see tonight, is that the customers really wanted Applied Materials to succeed. And I thought, well, with that base and our set of products and the technology we have, we could build a company. The first equipment was made in-house. In fact, when I was first came in the industry, it was expected that IBM or TI or Motorola or Fairchild would really become the leader in the semiconductor equipment side. In fact, some of the early days when Mike McNeely, our founder, working with Jean Hornet and others to develop a product, came out, and in fact, we delivered one of the early products in the trunk of a car. So much for clean manufacturing. Yes, our industry is very proud to have contributed to the semiconductor industry, and I'd like to thank you for your support that has made our contribution possible. Thanks a lot.
Melvin Sharp joined Texas Instruments in 1962 and served as its general patent counsel and senior vice president. So as I thought about this, I realized here I am, an ex-engineer, giving an award to a lawyer in a room full of engineers. Then I remembered I was married to one, so it made it all right. But anyway, Mel was with TI from 1979 to 1991, and he's responsible for worldwide intellectual property acquisition, licensing, and enforcement. And he was instrumental in leading TI's move to create significant revenues from the intellectual property it owned. These revenues have cumulatively exceeded $3 billion over TI's history. While companies like Rambus are perfecting the IP licensing model today, Mel literally wrote the book, several actually, on using intellectual property litigation to enhance corporate profits as well as Japanese practices in licensing. Much of this knowledge comes from his own experiences at TI. Currently, he's the CEO of Sharp Comfort and Merit PC in Dallas, a firm specializing in evaluating and licensing of intellectual property rights. It's my pleasure to welcome Mel Sharp.
It's a pleasure to celebrate the 50th anniversary of the Silicon Chip with you. My career spans over 40 years associated with semiconductor technology and intellectual property rights. I remember in the mid-1950s when I was an engineering student at the university, there was no course in transistors or transistor circuits. We were studying vacuum tube theory and vacuum tube circuits. One day, however, one of my engineering professors came in, all excited. The silicon transistor had just been reduced to practice, and he was convinced that transistors would be an important technology. In his exuberance, he offered to teach interested students on an informal after-hours basis transistor structures and transistor circuit theories. I was one of 5 students that showed up for his class. That brief transistor course that I took landed me a job in the U.S. Patent Office a couple years later, and I was assigned to the division that examined patent applications on semiconductor technology. I remember very active at the time was Bell Labs, Fairchild, and Texas Instruments. And seeing the inventions and examining those inventions whetted my appetite to be a part of semiconductor technology. Later on, as a patent attorney, I became familiar with the patents of the awardees tonight, and they truly are landmark inventions that laid the foundation in the semiconductor field. I became familiar with the awardees through their patents, and it's been fun for me tonight to put faces to the patents I had been arguing about for all these past years. I'd like to congratulate the awardees for creating such an exciting technology and making the dreams of the 1950s and 1960s come true. And more specifically, I'd like to thank them for what an exciting career they've made for an intellectual property attorney. Thank you.
Wilfred Corrigan has been part of the semiconductor industry since 1960 when he left England to join Transitron. Currently, he's chairman and chief executive officer of LSI Logic Corporation and has been one of the industry leaders in the current industry trend towards systems on a chip. Prior to founding LSI Logic in 1981, he was president and chief executive officer of Fairchild Camera and Instrument Corporation, having joined Fairchild in August 1968. Wilf is a director and past chairman of the Semiconductor Industry Association, and here to share his thoughts with us on the birth of this industry is Wilfred Corrigan.
Seeing some of these slides tonight and looking at that first transistor in 1947, I got into the industry in 1960, and the stuff that I worked on didn't look that much different than what you saw on that slide. The question is, how do you get into the transistor business? And I guess I got into it because I needed a job. And I graduated from the University of London, and I'm a chemical engineer, and I was looking for a job outside of England, any place outside of England. And I had 3 job offers. One was a gunpowder factory in Australia. The other one was a methanol plant in Germany. And the third one was this company in just outside Boston, Wakefield, that made transistors. And I had a 3-minute interview with the president of the company in England. And 2 weeks later, I got a job offer and a plane ticket. So I get to Boston on a Sunday night, and I start work at Transitron the next Monday morning. And they were very efficient in the personnel processing, much, much better than what we do today. I showed up at 8 o'clock, and by 8:30, I had a metal desk. I was all checked in. I was an official employee. And so I'm sitting there, and nobody's told me yet who I work for, what the job was, and almost nothing about the company. So being logical and being well-trained in my university, I went down to the little library they had, and Pierre Lamont probably remembers that library. There's a few Transitron graduates in the room. And I checked out this book that actually said transistor on it. And so I took it back, and it's now about 9 o'clock, and I'm sitting at my little desk, and I'm on page 1, transistors, halfway down the page. And the door bursts open. And there's this guy comes in, kind of a rough-looking sort of guy. And he says, "Are you the new engineer?" And I said, yeah, I'm the new engineer. And he said, "We've got a whole line shut down here. And there's 200 women sitting on their hands, and you're sitting at your desk reading a book." So that was my introduction to the semiconductor business, and it's been more or less the same ever since. When a bunch of us started LSI Logic in 1980, we were shipping our initial product was about 20,000 transistors on a chip. And if we got $20 for that, we felt pretty good. So that was about 1,000 transistors for $1. Today, if somebody would give us, $50 for a couple of million transistors, we'd be thrilled and delighted. And now you think about it. How many things in history have you seen a 1,000,000-time reduction in the price? not the cost, the price. And the industry's grown from $200 million a year to close to $200 billion a year. I mean, that's, rather startling sort of figures. And that's the wonder of this industry. And it might be when everybody's talking about maybe we're into a deflationary area, sometimes I think that we individually in this room are creating the deflation. Thank you.
It's my pleasure to introduce or to present an award to Dr. Carver Mead. Dr. Mead has actually taught at Caltech for 30 years. He began his career in semiconductors, then a branch of applied physics back in the late 1950s. His career in VLSI began in the late 1960s when he began to ponder the limits of silicon MOS technology. It was clear to him then that someday we're going to be able to put millions of transistors on a chip. However, his concern was, what kind of thing would you do with millions of transistors on an IC? I believe that this million transistor thinking in the late 1960s led him to the conclusion that ultimately wiring, not transistors, would be the main problem in semiconductor design. These considerations have led to the birth of tools addressing deep submicron, or as some people like to say today, very deep submicron tools for 0.25 micron or 0.18 designs. And as it results in EDA, electronic design automation, which is the industry that I cover, that's one of the hottest and fastest growing areas, growing 3 to 4 times the overall industry. It's my pleasure to now introduce Dr. Carver Mead.
I was working in the mid-60s on electron tunneling, and we were making thin insulating layers, and if you made them thin enough, the electron wave function, which was dying out exponentially with distance, would get through to the other side, and you could get some current out of it, and that was a very interesting phenomenon. And I was, doing my weekly commute up to Fairchild, and I was talking to Gordon Moore. I think it was 66 or 67, and he said, "Carver, that means that if you make something small enough, it starts to leak, doesn't it?" Yeah, Gordon, that's what it means. Said, would that limit how small you could make a transistor? Oh, yeah, well, let me think about that. So I went off and thought about that and sort of worked out how small you could make transistors and thought a little about what would happen if you made them smaller and stuff. And the more I worked on that, the more remarkable it was, because as you made the transistors smaller, you could scale things down in such a way that they got faster, you could get more of them on a chip. Well, you've all gone off and done that, and it's a wonderful industry to be in. Thank you much.
The awards thus far have been for technical innovation. These final awards are presented to the recipients for their business acumen and their contribution to the industry in terms of the business itself. 10 years ago, a brand new business segment in the semiconductor industry was invented by Dr. Morris Chang. With the establishment of the world's first dedicated IC foundry, TSMC. This was considered at that point a bold and risky venture by the industry. However, with TSMC as the engine of change, what was once just a one-man idea is today multi-billion dollar industry. TSMC's success in the foundry business has served as a model for many new market entrants. IC foundries have facilitated spectacular growth for fabless semiconductor companies over the past 10 years. In the next 10 years, as the semiconductor industry faces greater consolidation, challenges, and the spiraling costs of the implementation of these multi-billion dollar facilities, foundry companies will continue to be a major source of IC manufacturing services, not only for those fabless semiconductor companies, but for integrated device manufacturers. Dr. Chang's innovative approach has benefited companies in terms of accelerated time to market, in terms of their cost effectiveness, and certainly in terms of reducing their capital risk. That is why we honor him tonight. Please welcome Dr. Morris
Thank you, Brian. The wafer foundry industry has had only a rather short history so far, 11 years. I think that the challenges in the 11 years could be divided into two periods. In the first period of perhaps 6 or 7 years, I think our challenge was, of course, first to survive. But then, even more importantly, our challenge was to reduce the entry barriers into the semiconductor industry. We were, I think, quite successful in doing that. Without the wafer foundry industry, I think the entry price by now would probably be a couple $100 million. But now I hear of people who have only $5 million that start semiconductor companies. So I think we've been reasonably successful in reducing the entry barriers into the semiconductor industry. That promotes innovations. I believe it's good. Now, we've been successful enough that we now, in this second period of the industry, face a new challenge. And the new challenge is to increase the entry barriers into our own industry. Well, very luckily, while in the first period we were acting almost alone without very much help, in the second period we do have a lot of help. First of all, people like Jim Morgan and then Maydan, they got awards for pioneering the equipment industry, and as you know, the cost of fabs is, just escalating. $500 million, $1 billion, $2 billion, pretty soon will be $3 billion. Surely, all they are doing can't help but increase the barriers of entry into our industry. So while they got a full award in the ceremony so far, I want to give them half award at least for having helped us to raise the entry barriers into our industry. The second help we're getting, I think, more seriously is from our customers, our partners. They are so relentless in driving us to excellence that before they are through with us, I think we'll be so good that nobody can compete with us anymore. So I want to thank them for that. This award really should go to them. Thank you very much.
Our last award this evening is presented to Andy Grove, Chairman and CEO of Intel, for his outstanding business acumen and for the way he has aggressively redefined and transformed the semiconductor industry. As a scientist, Andy has participated in bringing about major breakthroughs in semiconductor technology. As an entrepreneur, he helped found Intel Corporation and envisioned the industry's growth dependent not just on new scientific breakthroughs, but on the development of new markets for chips Intel and others build. To ensure Intel's continued success, he maneuvered to make the PC the central appliance in our lives. To back up his philosophy, he put Intel on a treadmill of new product introductions fed by increasing demand for microprocessors. His character traits are emblematic of this amazing century. Paranoia bred from his having been a refugee from the Nazis and then the communists. Entrepreneurial optimism instilled as an immigrant coming to a land brimming with freedom and opportunity. And a sharpness tinged with arrogance that comes from being a brilliant mind on the front line of a revolution. The digital revolution that his philosophy helped create is now transforming the end of this century the way the Industrial Revolution transformed the end of the last one. And as Time magazine said in naming him recently the Man of the Year, quote, "The story that had the most impact on 1997 was the one that had the most impact throughout this decade. The growth of a new economy, global in scope, and propelled by the power of the microchip." Behind it all was Andy Grove, and we honor him here tonight with this 50th anniversary award. Though he cannot be here with us tonight, he took time to share some of his thoughts with us in the following video.
I was very fortunate when I got out of school to be assigned to work on MOS devices. It was a very fascinating field technically. None of us knew a whole lot about it, and we were all learning as we went along. And I had the additional fortune to be mixed in with two outstanding people, Bruce Deal and Ed Snow, who brought varied expertise to the field. We had a real good time working on this project, trying to make those drifting, unstable devices stable and reproducible. But I don't think any of us had an idea that what we were working on would turn out to be the basic building block of a huge and very, very significant industry. Maybe Gordon, who put us on this project, had an inkling. The rest of us sure didn't. One of the important developments in this industry has been really the evolution and the development of the personal computer. Almost overnight, the PC became the target market for much of us, much of the semiconductor industry, and the defining parameter for our work. And in turn, our work has propelled the PC into an ever powerful, ever adaptable, and ever more cost-effective device. The levels of performance and capability that our chips will bring 5 years from now, 10 years from now, are such that they are hard even to visualize or think of today. But as that is happening, I'm confident that the dynamics of the industry, where the utility of the device that we build will grow with that complexity, and with that utility comes mass demand, will continue well into the next century.
Now we come to the part of the evening that is perhaps the most important, the connection of all this historic work to the future. As you came in tonight, you might have seen some of the work going on right across the street. The facility under construction, a beautiful building designed by Ricardo Legarreta, a Pritzker Award winner, will by October of this year become the Tech Museum of Innovation. It will educate the next generation on the potential of technology and will include major exhibits covering everything from semiconductor manufacturing to semiconductor uses. Abraham Lincoln once said that our work today is not only for today, it is for a vast future also. Tonight, thanks to your generosity, everyone in the room, we are able to provide a concrete demonstration of that point. I'd like to ask Peter Giles, the director of the Tech Museum, to come forward. Peter, on behalf of all of tonight's attendees and supporters, I want to present you with a check for a minimum of $500,000. But since we didn't know exactly what the amount is because we got oversubscribed at the end, I should say that I should read what the inscription says inside this envelope. It says, "The check is in the mail."
Thank you, Sandy. Thank you, BancAmerica, Robertson, Stevens. Thank you, Dan Klesken, Applied Materials, Amcor Technology. Thank you, Intel. Thank you, the other sponsors and the honorees and everyone who is here tonight who is supporting this event. These funds will go toward our capital campaign for the new tech, as Sandy has been describing to you. Your help and support in this cause will help today's and tomorrow's young people see the opportunities, the possibilities in their own futures. Thank you all for your support again. Have a safe trip home and another 50 years of innovation and unbridled opportunities that the birthday party we've celebrated here tonight has brought to each of us in this room and beyond. Thank you very much.